So again, we're on the backside of worksheet 8.2 WSP, and I want to focus in on 22, 23, and 24. Let's start with 22. And of course, we are adding and subtracting fractions. And in order to do that, you need a common denominator. So what we do to find that LCD is first factor anything possible. So right here, there's nothing to factor. Right here, there's nothing to factor. Right here, you could factor. One option is to think parenthesis, AA, where you think what times what is -9, that if you combine together is the middle value, which happens to be nothing. So that would be a +3 and -3. Or yes, you could have thought of it as the difference of two perfect square terms. So you could square root it, get an A, square root it, get a 3. So A and 3, 1 plus, 1 minus, right? Either way, that's the factored form. So when you write your LCD, your new lowest common denominator for all three fractions, whatever repeats you write once, and whatever is left over you bring down. So when we're looking at this thing, what repeats? We have one A minus 3 there and an A minus 3 there. We're going to write down A minus 3 one time right there. And we also have an A plus 3 and an A plus 3. So you're going to bring down that A plus 3. And is there anything left over? No. So that's it. That is your LCD, A minus 3 times A plus 3. So the LCD is that, and I normally write that at the bottom of each of the fractions. And then from there, I go back and ask myself, what do I do to this first denominator to get this new LCD, which is the A minus 3, but with the extra times A plus 3? Obviously, it's missing the A plus 3. So you put A plus 3 both on top and bottom in parentheses because you are multiplying, which means you're going to have to distribute the 2A times another A, that'll be a 2A squared, and then 2A times the 3, and that'll be a 6A. Now, this next denominator is a plus 3. So how do we change this A plus 3 to become A plus 3 times A minus 3? Obviously, you're missing that A minus 3. So you're going to multiply by A minus 3. You're going to multiply by A minus 3. And you do have to distribute again. 2A times A is 2A squared. 2A times a minus 3 is a negative 6A. And last but not least, what do you do to this denominator to get the LCD? That is the LCD. So you don't have to do anything to it. So you don't have to do anything to that 36 right there. So you just bring it down. So now that you have that LCD in all three fractions, you could now add and subtract the numerators, and your answer will be over that LCD of A plus 3, A minus 3. Doesn't matter which order you put it, but that is the LCD. So now let's go through and actually subtract and add the numerators. So this one is very important that you recognize that that minus sign has to get distributed to both terms because it's a binomial in that numerator, okay? So before combining terms, that minus sign has to go in front of that 2A, making it a negative 2A. That minus sign has to go in front of that minus 6A, making it a positive 6A. So we've already distributed that minus sign in, so now you could actually go through and combine like terms. This 2A squared combined with this minus 2A squared completely eliminates, and you don't have to write it on your answer. And then the plus 6A with that plus 6A is actually a positive 12A. Okay. And then the plus 36 just comes down as plus 36. Now, that might be our answer, but we still need to try to factor further to see if we could further cancel anything out. So up on top, we're going to pull out the GCF of 12. And what would we have left over? A plus 3, right? 12 times A is 12A. 12 times 3 is 36. And so that's a new factored form numerator, and it's still over that LCD that we had, A plus 3, A minus 3. And that is correct. We can cancel the A plus 3 with the A plus 3, leaving us our final answer here, 12 over A minus 3. Okay, let's move on. Number 23. This one is extra fun. Oh yeah. So how are we going to do this? Well, first of all, we need to recognize that this is a division problem. It's a complex rational expression. Of course, you have something up on top divided by something on the bottom. So let's treat this as two separate problems. Let's actually look at just the top. Let's ignore the bottom for now. And up on top, we have the addition of two fractions, okay? So if I wanted to add the two fractions, I would need a common denominator, okay? So what would the common denominator be? Well, first try to factor anything possible, factor anything possible. Obviously, you can't factor anything. So what is the first denominator? It's actually the binomial x minus y. What's the second denominator? It's actually the binomial x plus y. You can't factor out anything. So what would the LCD be if I wanted to add those two fractions? What would the LCD be? In other words, if I wanted to, you know what? Let me do this. If I wanted to rewrite these two fractions up here, but with the LCD, how do we find the LCD? If there's anything in common, you write it once. Is there anything in common here? No, you have two totally different binomials. So there's nothing in common to write once. What do you do with everything else that's not repeated? You just bring it down and make it part of your LCD. So what is my LCD? It's this one and this one written right next to each other. You understand that? So I really have the x minus y times the x plus y as my LCD. So I do it to both x minus y, x plus y. So what do we do to this first denominator to get this new LCD? Well, what do you do to the x minus y to get x minus y times x plus y? It's obviously missing the times x plus y. So you're going to multiply times x plus y. You're going to multiply times x plus y, which means you're going to distribute 2 times x. That'll be a 2x. 2 times y, that'll be a positive 2y. And then you look at your second denominator, and how are you going to get this new LCD from the second denominator? Right here you have the x plus y. Over here you have the x plus y times x minus y. So obviously this is missing what? The times x minus y. Okay, so you're going to multiply both top and bottom by x minus y. And right here it's pretty simple because if you distribute a 1, it's not going to change anything. 1 times x is 1x. 1 times negative y is negative y. Anyway, again, remember, all we're doing is focusing in on the top. We're not even looking at the bottom yet. We're trying to find the answer to the top first, and then we could worry about dividing by that 1 over x minus y. But anyway, up on top, we now have a common denominator. We are now able to add the numerators, the x's with the x's and the y's with the y's, and write our answer over that common denominator, x plus y, x minus y. Okay, so let's combine the numerators. We have addition. So when it's addition, it's really easy because even if you did distribute the plus sign, it doesn't change anything. Now, if it were a minus, yeah, you'd have to change that sign and change that sign. But the plus, you could just start combining already. So let's combine the x's with the x's. We say 2x plus one more x. How many x's is that? 3x's. Yeah, 3x's. Okay, thank you. 3x's. And then how about 2y plus a minus y? That's 1y, right? So plus 1y, or just plus y. So that is our answer to the top situation of adding these two fractions. That's my answer to the addition of these two fractions. Now, we do have this divided by this fraction. So you could write the division of that exact fraction 1 over x minus y. But yes, we're going to have to change the division to multiplication and flip that second fraction. So here's the multiplication, and we're going to flip this second fraction. So the first fraction is going to stay the same, 3x plus y over x plus y, x minus y. And the other one flips to a x minus y up on top over a 1. And yes, we can look at the entire binomial x minus y on top with the entire binomial x minus y on the bottom, and those are identical, which means we could cancel them. So that means that this is our final answer, 3x plus y over x plus y. Now, some of us might be thinking, why can't I cancel this y with that y? Well, because there's addition going on. Remember, it has to be pure multiplication. That's the reason why we factor, to get multiplication to be able to cancel. Okay. So this is our answer right here. Let's move on to number 24. Let's have some fun. Oh, yes. Again, we're going to treat this like two separate problems. Okay. I'm going to focus in on this top subtraction of two fractions first, and I want to get an answer. Once I get that answer, which is probably going to be a fraction, I'm then going to worry about dividing it by this fraction, which I'm going to change the multiplication and flip the second fraction. But anyways, a piece at a time. Let's start with two fractions that are being subtracted. In order for me to subtract two fractions, obviously I need a common denominator, okay? So you factor out anything possible. There's nothing to factor. There's nothing to factor. And when you do factor out anything possible, what you do is whatever repeats in both, whatever is duplicated in both, you write it one time and then you bring down everything else. So nothing is duplicated in both, right? So you're just going to have to write everything together. So what is my common denominator going to be? It's going to be r times r plus 2. So r times r plus 2, that is my common denominator. So I write it twice on both fractions, r times r plus 2. Now the question is, how do I change this r to become r times r plus 2? It's obviously missing the r plus 2. So we're going to multiply both top and bottom by that missing r plus 2. Now this is where it gets a little fun, because we actually have a binomial r plus 6 on top that I need to multiply by this binomial r plus 2. So when I do this, I need to distribute and then combine like terms. R times r is r squared. R times 6 is 6r. And then I would distribute the 2. 2 times r is 2r. And then 2 times 6 is 12. And then I could combine the middle terms, 6r and 2r, and actually get 8r. So the middle term is plus 8r. And you do have the plus 12 at the end. And you do have the r squared at the beginning. Now we look at our second fraction and we realize that we have the denominator r plus 2. What do I need to do to this r plus 2 to make it this LCD r plus 2 times another r? It's obviously missing that other r. So you're going to multiply both top and bottom by r. And that one's easy to do. 1 times r is simply r. Okay, now we have a common denominator, r times r plus 2. And now we're able to subtract the top with the top and write it over our common denominator. So our answer is going to be over that common denominator, r times r plus 2. Okay, so what is the answer? Well, you're going to start with your highest exponent term, r squared. R squared minus, there's no other r squares, so it's just r squared. And then we move on to 8r minus r, 7r, right? So positive 7r. And then last but not least, 12 minus, no, there's no other number, so it's just 12. So just positive 12. And there you have it. That is your answer. But then again, whenever you have a fraction as an answer, you try to simplify it, right? So if you could factor it, you better factor it. So let's actually factor that quadratic trinomial up there, that r squared plus 7r plus 12. Maybe it could be factored to r and r, thinking what times what is c, that if you add together is b. You might want to make a list: 1 times 12, 2 times 6, 3 times 4. And of course, that'll be a 3 and a 4, a positive 3 and a positive 4. So I've changed this numerator to become this factored form, binomial times binomial, and it's still over the common denominator, LCD r times r plus 2. So what was that? So that's as far as you could go. That's as far as you could simplify the numerator of the original complex rational expression. So anyway, let me rewrite this thing. So again, the answer to the top is this. There's nothing to cancel here, but the answer to the top is this. And now we're going to go to the division. This division bar is going to be written as a division symbol. and we're going to divide it by this bottom fraction. I'm just going to rewrite that fraction right there to the side. Okay, so now we know that when we have a fraction divided by a fraction, we could really change the division to multiplication as long as we flip this second fraction. So, well, it's getting ugly. Sorry. So we're going to take this division, change to multiplication as long as we flip that second fraction. And as I flip that second fraction, I might as well factor it because you want to factor everything possible. So the denominator, r squared plus 2r, we could pull out a GCF as we move it to the top. So as we move it to the top, we're going to pull out the GCF of r. And what would we have left inside of the parentheses? If I pull out a r, what's left in here? R plus 2, right? R plus 2. Okay, now this top one, it's a quadratic trinomial with no number in the front. So as I move it down, I might as well factor it to parentheses, r, thinking what times what is the c value that if I add together is the b value. So what times what is 3 that if I add together is 4? Positive 3, positive 1. That'll give you 3, and if you add it together, it is 4. So now we have the division and multiplication. It got flipped and it's factored. Let me bring this one down. And now that everything's factored, it all has multiplication. Now we could cancel out anything we see on top and bottom. So we see a r plus 3 up on top with the r plus 3 on the bottom. We see a r plus 2 up on top with an r plus 2 on the bottom. We also see a single r and a single r that we're able to eliminate. So this is our final answer, r plus 4, even though that looks like a 9, sorry about that, r plus 4 over r plus 1. That is your answer. And you cannot cancel out the r's because of the addition. So you could consider these the hardest questions on the worksheet. There will be nothing more difficult than this on the actual quiz this Friday.